all my French. Sorry for that. Okay, so yeah, let's talk about the world of Dart only plugins. I think I had a different idea for a title, but it was going to be too big, but it's in the slides anyway. Okay, not important stuff. My name is Renan Araujo. I am from Brazil, but recently I moved to Portugal. So I live in Portugal, in the city of Porto. I work at Very Good Ventures. It's a consultancy company in the US, specifically focused on Flutter. I work as an OSS engineer. So this means I maintain open source packages and tooling that we have, all of them around Flutter and Dart. And also, I am an OSS contributor in the collective. It's not a company or anything like that, but it's a collective of folks that love Flutter. It's called Bluefire. And among of, I love Bluefire. There's someone else from Bluefire there. And among the packages that we maintain, there's Flame, the Flame engine, which we're going to have a talk in the end of the day today here with Lucas. Okay, so, important stuff now. I'm going to talk about something that has been living in my head rent-free for a couple of months now. So as a Flutter developer, when you talk about accessing native features, there's just mostly one way you think about that you can have access to those things. And those are the method channels, so the usual way of building plugins. But recent developments in Dart allows us to have access to native APIs in a different way. So I'm going to just try to give a fast sneak peek on it because it's an extensive topic, the FFI. So let's go for a quick sneak peek and hopefully an example. All right. So first and foremost, let's look into how plugins are built. What's the structure of Flutter plugins today? So to do that, we have also to understand the structure of a Flutter application. So every Flutter application that we write has this structure that here we're going to represent as a bunch of rectangles. That's a fun way to represent things. Actually, this diagram you can find in the actual Flutter documentation. It's Anatomy of an App. I really recommend the documentation. It's pretty fun. Okay, so when we talk about writing stuff, everything that we write, state management, all the widgets that we write, the packages that we use, the Dart package that we use, they're all in this first layer that we call the everything we write. It's the app that we write, everything under lib. After that, below that, we have the Flutter framework. That's the Dart part of Flutter that sustain whatever we do. So material, all the widgets, API, all the gesture recognizers. So everything under Flutter /Flutter on GitHub, it's on the framework. And then sustaining the framework, we have, that's the problem of Keynote. There is the Flutter engine. Okay, so the Flutter engine is mostly C++, so it's where there's the core APIs for Flutter. Things like the graphics core or text composition, for example. And also there is an API that we access sometimes. If you work a lot with the canvas, there's the Dart UI that comes from the engine. So mostly C++. And then there's embedder. This part is the thing that connects Flutter to the platform. So this is where we have access to the platform's gesture engine, for example. So yeah, so this is the embedder. So it's specific for the platform. So for example, on iOS and Darwin, actually it's Objective-C. And Windows, for example, is C++. And then we have something else that we have access to. It's actually everything under the platform directories. So under Android, under iOS, there's the runner application. So this is the actual thing that we will compile and send to the store. So we call the runner. It's also written the platform code. So yeah, that's pretty much how a Flutter application works. So the two parts that we have access are these two blocks of codes, the top one and the bottom one. And when we want to write a bridge between these two parts, we have something that we call the method event channels that we can, from the Dart side, to call native things that we can write the counterparts in the runner. Plugins are a way to modularize this thing. So plugins are usually part Dart and part native code, and the Flutter tool takes care of putting these two boxes, especially the platform code embeds in the runner, and our Dart code is a Dart package. So yeah, this is how plugin works. Normal plugins work. So today, I'm going to show how different it is if you go for a Dart-only thing. So a Dart-only plugin, basically, you write like this. This is a France flag. I try to do some kind of a homage here. So there is the plugin part, is where you write the functionality that we want to write. So it's always related to the feature of our package. And then we call what we call bindings to the native API. So this is still Dart too, and it's most cases generated using either the FFI JNI tooling. It's a package that there's there, or you can directly use Windows 32 if you are targeting Windows. You don't need to generate the bindings anymore because TeamSniff did that for us. So with the Windows 32 package, you have access to bindings to virtually all Windows 32 APIs. So yeah, and then these bindings can load what we call, this is key in this case, the dynamic libraries can load in runtime, and this lives in the registry in the operating system. So yeah, so basically, this is how it works. You have the plugin package that we isolate the functionality, and we call the bindings, and the native libraries are in the operating system. So it's totally independent of Flutter. It's an actual Dart package. So most packages that are written like this can be used on Dart CLIs, for example. So it's totally independent. And yeah, some more differences. Calls are totally sync, and since they are generated, the APIs are generated, they are somewhat type-safe. So type-safe calls, they're sync, there is no dependencies on Flutter, and yeah, in packages that depends exclusively on this, you don't need to have any setup when you install the package. Just install the package, start using. Okay, so let's go for an example. So let's pray for the gods of live code today. It's actually not code, I'm not be coding here. It would be crazy on a lightning talk. Just want to show something. So this is an application I wrote. So this is just a text field, like in text fields, material and stuff, and some buttons, so a basic Flutter app. But the thing here is we can write anything. Okay, I'm going to write this text here, and I copy, and this copies with formatting. So I copy with the HTML format, and I can go to some document. In this case, I'm on some document, and pass here, and we will pass with the formatting, the same formatting that I copied here, basically. And this works on both macOS and Windows. So let's look a little bit into the code here. So I isolated everything under this packages directory. So I wrote in a way that looks like a plugin that's federated. If you know what the federated plugin in Flutter is, it will be, you recognize here some patterns. So the front-facing package that we have is only this function that we just, by platform, we select the correct implementation. So we have implementation for Windows, and another one for macOS. Sorry, Linux folks. Okay, so for Windows, for example, this is what FFI code looks like. Looks pretty much close to Objective-C. So if you ever wrote something that puts anything in the clipboard on Windows, this is the basic boilerplate. We allocate memory, we lock memory, we write stuff in the location in the memory, then we open the clipboard, write in the clipboard, close the clipboard, free the memory. That's it. control memory allocation all the time. But this, most importantly, is it's all Dart. But at the same time, it's kind of isn't. These classes are all the actual interfaces of C++ classes that lives in the Windows 32 package. I guess this is specifically in the user 32 framework on Windows 32. So yeah, and this is how we write, or how we read from the clipboard, and then we put everything in a common interface that's it's implemented by both macOS and Windows. So let's look into the macOS implementation. So if you ever wrote anything to the clipboard on macOS, you're going to recognize, and even if you wrote Objective-C in your lifetime, you're going to recognize some elements now. Here, we have bindings to the actual NS passport class that lives on the app kit, actually Cocoa. And yeah, we get the general clipboard here, passport, sorry. And yeah, we have methods. Writing the clipboard on macOS is pretty more simple. You don't need to allocate memory or anything. But still, you have set string for type, and we have support for the actual types here. So we can put all of these formats on the clipboard on macOS, and we have the actual bindings here. And if we look back into the NS passport class, it actually, this file is so big. NS passport. NS passport. Come on, it's a class. Here, it's extend NS object. This is kind of crazy, and it's Dart. And these bindings, we don't have yet something like a package Windows 32 for macOS, so I had to generate my own bindings here. So I put this in this package, AppKit bindings, that basically uses the FFI gen. So I'm going to show a little bit of the configuration here that I used. We use a header file in the system to generate the bindings, and then the package loads the dynamic library from a dylib. So this is on Windows is the DLLs. On Linux is the SO files. And this is a dylib we load in runtime. And then we have the AppKit binding ready to use. OK, so yeah, that's pretty much the example. And then, OK, and the Flutter side of things, we have the HTML that we copy and we put these tags, italic and bold. That's pretty much it for the example. All right, so we have some drawbacks on the thing. First, there are some severe multi-threading limitations when it's about macOS and generating bindings from Objective-C. Some APIs on macOS can only be called if you are in the main thread of the application. For example, creating window. So if you create an NS window, your application will crash in runtime because the Dart isolation doesn't run in the main thread of macOS, of a macOS application. And that's pretty limiting for some APIs, for some specific frameworks. For example, Game Controller, which was my initial intention to show off today. So yeah, this kind of stuff is limiting, but there are use cases. There are password, sound, for example, those things work. And okay, there's some ways you can load dynamic libraries. The dynamic library open, you load the library in runtime, and it's unclear how Apple will treat your app if you submit your app using this. You can use dynamic library process because some frameworks are packed directly into the IPA, so those things are available already in build time. So you don't need to call open, but still, it's not clear how Apple will deal with that too. Okay, and there are some other use cases coming on. There is, I think a highlight is the JNI gen. JNI gen is a way of generating bindings to the JNI, which is the Java native interface. So basically, it's just like this, but for Java-based operating systems, for example, Android. So there's a nice video about this from Google I/O. And yeah, there's more stuff. I put everything in the link here, and this example is also open source on my GitHub. So yeah, that's pretty much it. Do we have time for questions? I guess.
Right. I start with the very important questions. I mean, how can you actually write Objective-C code without square brackets? I mean.
Yeah, I mean, this binding is the fun part of this. It's we don't need to actually write those things. They were generated by FFI Gen. So these header files, they contain the interfaces and the methods that we can call. And then the FFI Gen creates the Dart versions of these APIs. Of course, in some cases, for example, we just saw on the Windows implementation, you still have to care about all the memory allocation stuff. So it's very sensitive, especially on Windows, the clipboard thing. If you don't open the clipboard after you write on it, it will be closed for all programs.
Okay.
So it's pretty sensitive in that part. I guess that's kind of a drawback too in this implementation, but it's still Dart, you know.
So I have another question, Renan. I saw that there are those prefix NS window and on the all Objective-C objects. How would naming conflicts would be handled if you have some classes named the same between Objective-C and Dart? How does it work?
Yeah, this generated code all lives in one file, specifically in that generation there, which is pretty big. So the NS stuff are all, I think the FFI Gen manages name conflicts by itself. So you have, I could show there, there's NS object 1, NS object 2. Okay. So the internal parts, they increment names to avoid name conflicts there. But because everything is inside one Dart file, it's isolated to that library. So if you are importing two different files with the same name, you just use the show or hide syntax, just like any Dart code. Yeah.
We have a question from Alois. How much FFI bindings affect bundle size? And there is any sort of tree shaking for that?
Yeah, you can optimize how you generate the things by passing some options. So you can either exclude everything and include only the interfaces that we want and the dependencies of it. So it kind of is a tree shaking in the generating time. And also Dart has tree shaking compiling. So from my trials, it doesn't affect that much. It's just once you use something like, for example, NS Password, inside of its implementation depends on a lot of classes. So it's not only the classes that you use, but the dependencies of that classes. And that can increase depending on your use case. But it's in the end, it's not that huge. The biggest problem in this case, it's not the case that this example that we're using dynamic libraries that in the operating system, you can ship the dynamic libraries with the application. In this case, AppKit, the dynamic library is always shipped if you're using or not this kind of implementation. So if you create your dynamic library, that will go to your bundle.
Yeah.
We have another question from Mathieu. Can FFI be used to create a plugin for Cocoa Pod library, not already included in Flutter?
Yeah, I think that's the case that we just showed here. Actually, an S password is originally in Cocoa, so we are getting from the AppKit header. Yeah, so yeah, sure.
Yeah, it's pretty useful, I guess. So in that case.
Definitely.
And what about memory? You know, if you did some iOS, you know, Objective-C has like very old-fashioned way to handle memory. Is that actually handled well by Dart, who actually holds strong references to NS objects?
Yeah, it's still the bindings for Objective-C is still something preview. I forgot to mention that. For Windows 32, there's already a package, and there are already people using that in production. But for Objective-C, it's still in development. So this is kind of a sneak peek into the future. And memory allocation and memory management is still in the things that they're still trying to figure out in some aspects. But from my use cases there, I couldn't find any kind of memory leak after some several trials.
All right.
So yeah, I don't think it's something that's ready now for production by any means, but it's pretty close.
Okay. Nice. All right.
I think that's it.
Perfect. So thank you very much. And this closes also the first part of talks for this morning. And so you will be able to enjoy a coffee break until 11:20. So like 20 minutes for taking a break. And so see you later. Thank you.
Thank you, Renan.